Okay, so this is question 3 of the MTH240 midterm, and question number 3. It says solve the following initial value problem. Solve explicitly for y of x. So this problem is a differential problem. You can see that we're given a differential equation here, y prime plus y is equal to cos e to the power of x, and we're also given this piece of information, y of ln pi is equal to 2. And so in MTH240, which is calculus 2, we learn about two types of differential equations, or two methods of solving them, and that would be the initial value problems, IVP, and separable. And so typically separable is seen as an easier method, and if it's possible, it is recommended that you do the separable method. However, in this case, it does state that we need to solve the following initial value problem, so we're going to use IVP. Okay, so the first thing we have to do is there are actually two formulas that we need, and those formulas is the following. So we have to have our differential equation in the form of y prime plus p of x times y is equal to q of x. And this isn't it could be it depends on what textbook you're using, but this is basically the gist of the formula. You could instead, if you want, you could put like g of x, and then for q of x you could put h of x or something, but generally this is essentially what it is. The notation doesn't really matter too much. And so this is the first equation, and we also have another equation that we're going to have to use. And once again, the notation isn't very important, but this would be the second equation that we need. And so these are the two equations that you're going to need to use when solving a IVP. So now let's actually start. So the first thing to do is we want to make sure that we have this differential equation, and we want to manipulate it such that it is equal, it is in this form. And we can see that it pretty much is in that form right away. You see we have the y prime, we have the y prime plus the y, and I mean technically here you can think of this as 1 times y, meaning that the 1 is actually our p of x and the y is our y, and then we have this as our q of x. So we basically have already done the first part of this, and we've used essentially the first equation. It's not really an equation, since you just have to make sure that it's in this form. So our differential equation is already in this form, so let's just write it down. Y prime plus y is equal to cos ex, and we know that it's already in the form, so we can go ahead and now use this one right here. So mu x is equal to e, and once again p of x is technically the imaginary one that is being multiplied by the y, and so this gives us a very easy, simple integration. We know that the integral of 1 is just x, so this means that we have e to the power of x, and there we have it. So now what we have to do is we have to multiply this to our whole differential equation. So that means we have to now multiply this to both sides of the differential equation that we have. And so this ends up becoming e to the power of x times y prime plus e to the power of x times y, which is equal to e to the power of x times cos e to the power of x. Now from this step on, we can see what we want to focus on is this right here. And so this right here if you haven't noticed already, you can actually tell that this right here would be equivalent to the dot product, oh sorry, not the dot product, the product rule of EX times Y. If we differentiate this, what do we get? Well, e to the power of x times the derivative of y, that's just, y prime, and then plus y times the derivative of e to the power of x, and we can see these are the same. So that means we can rewrite it like this. So now let's rewrite our equation. So then we have e to the power of x times y in our brackets, and this little apostrophe just denotes, differentiation. And so that is equal to e to the power of x cos e to the power of x. And so now we have to differentiate both sides. So now this side, we know that if we're differentiating and then we're integrating. So that just cancels out. So this term right here, this would just be left as EXY. Boom. However, this side now, here we actually have to integrate and find the actual answer. So we have to now go ahead and integrate this. So what can we do? Well, we know that we can use u substitution. This isn't too complicated of an integral. So let's go ahead and let our u equal to e to the power of x. And that means what? That means our du would just be e to the power of x dx. And so that means our dx is equal to du over e to the power of x. So if we now go ahead and solve the following integral, let's just keep this on the side for now. Okay, we would have actually, let's go ahead and write this as du over u, because remember, u is equal to e to the power of x, so we can just write it like that. So now let's write our integral. So u cos u times du over u. You can see that this u and this u cancel out, leaving us with just cos u du. And this is a very simple integration, very basic. This is just equal to sine u, and so we can undo our u sub now, and that's equal to sine e to the power of x plus c. Bam. So now that we have this, let's go ahead and write. So e x y e to the power of x multiplied by y is equal to sine e to the power of x plus c. You want to make sure to actually include the plus c in your when we're writing the answer. So we have the plus c now. Now what we have to do is we have to actually find that c value. So how can we find that c value? Well, we are going to be using this piece of information right here. The y of ln pi is equal to 2. If we think about this, this is technically our x, and this is technically our y. So really, this is just giving us a coordinate of ln pi 2. And so this is giving us a coordinate. So this coordinate is going to be used to find our c value. So let's just go ahead and write our coordinate down. So ln pi 2, this is our x, this is our y. Now we're going to plug this coordinate into this equation that we just created. So e to the power of ln pi times 2 is equal to sine e to the power of ln pi plus c. And so e to the power of ln, that cancels out, that cancels out. And so really, this leaves us with 2 pi is equal to the sine of pi. The sine of pi is equal to 0. So we're left with c, which is equal to 2 pi. And so we've now found our constant. So now all we have to do is simply rearrange this equation we have here for y of x. And essentially all we have to do is really just bring this to this side. How would we do that? Well, we would essentially multiply this by 1 e to the power of x, so that this and this would cancel. So that's all we have to do now. So let's go ahead and write that. So then, y of x is equal to 1 over e to the power of x sine e to the power of x plus 2 pi, which is our c. And that is pretty much how we would solve this initial value problem.